Hi, this video is going to explain how to do rational equations with literals. So we know that rational equations are equations with fractions that have polynomials in either the numerator or denominator. What it means to have literals is that instead of numbers and variables, we are just going to have letters. So it's rational equations with letters instead of numbers, basically. Now, in the first example, which was a 2-point question on the regions, we have the focal length f of a camera's lens is related to the distance of the object from the lens, j, and the distance of the image area in the camera, w, by the formula below. When this equation is solved for j in terms of f and w, j equals what? So basically the top of the question was useless, but they did say that they want the equation solved for j, and what that means is that we want to have j by itself. We're going to solve j equals something. In order to do that, because we have three fractions, you need to find your least common denominator, which is your LCD. And we know that the LCD is just a combination of all the denominators that we see. So our LCD is JWF, FJW, WFJ, whatever combination of the letters that you want. That means when we have our equation, 1 over J plus 1 over W equals 1 over F. We are going to want to multiply each fraction by what's missing. So your first fraction has J in the denominator, but it's missing the W and the F. So I'm going to multiply by FW. Second fraction has the W, but it's missing the J and the F. So I'm going to multiply by FJ. And again, you could put these letters in any order that you want. Alphabetical order is the more typical order to use though. Our last fraction has an F, it's missing the J and the W. So when we multiply all of these by what's missing, we're going to get FW over FWJ plus FJ over FWJ equals JW over FWJ. And now that you have the same denominator, we can cross it out because we got the denominators equal. Now all we care about is getting the numerators equal. And we're going to be left with a new equation, FW plus FJ equals JW. Now we do want to get J by itself, so you're going to bring all the terms with J to one side. This kind of turns into the hard question that we did with inverses, where you have to get y by itself when there's a fraction. You always want the variable you're solving for on one side of the equation. That way you can take out a GCF. And when you take out the GCF, we're going to be left with J times, when you take out J, you are left with W minus F. And to get J by itself, because it's J times something, what undoes multiplication is division. So this is going to be divided by W minus F. And that leaves us with FW over W minus F is equal to J, which would be choice 3. Let's try 2 more. In example 1, they want you to solve for y in terms of E, N, K, and T. And in order to solve for y, we are trying to get y by itself. Now, you could write this as 3 fractions and multiply everything by what's missing. You can get the common denominator of n, absolutely. However, there is an easier way to do this problem. If you want to get y by itself, first of all, get rid of the k. You're going to have EY over n equals t minus k. In order to get rid of a denominator, you need to multiply by it. So I'm going to multiply by n. And I'm going to get ey, because my n's will cancel out, equals n times t minus k. And to get y by itself, you just divide by e. So y is equal to n times t minus k over e. If you would really prefer, you can distribute the n to get y equals nt minus nk over e. So there are a lot of different ways to do these problems. If you wanted to, instead of just multiplying by n, if you wanted to get rid of the e as well all in one shot, you could have multiplied by n divided by e, right? If you have a fraction and multiply by the reciprocal, it gets rid of the fraction entirely. So if you multiplied both sides by n over e, that would have given you y equals n over e times t minus k, which is an alternate answer. The choice is really yours how you solve it. Last one we're going to do is problem number 2. We want to solve for b, so we're getting b equals. My LCD is just the combination of everything I see in the denominator, which is ABC. I take my equation, each piece by what's missing. A is missing the BC, the AB. When you multiply everything together, you're going to get BC over ABC denominators. And when you get common denominators, we don't care about them anymore. We're trying to match up our numerators now. So we're really left with BC plus AC equals AB. And remember, we are trying to get B by itself. So we need to get B on the same side of the equation, whether it's the left or the right, I don't care. I'm going to bring my BC over to the right, but if you wanted to, you could have brought the AB to the left. Now I'm going to have AC equals AB minus BC, for which now there is a GCF because they both have a B in common. So when you factor out the B, your leftovers are going to be A minus C. This is B times A minus C. So in order to get rid of multiplication, you have to divide. That means our final answer is going to be B equals AC over A minus C. And remember, if you had a different order of the letters for the numerator, let's say you had CA over A minus C, that's fine because multiplication is commutative. You can switch the order of it. What you can't have is your denominator being C minus A, because subtraction is not commutative. You cannot switch the order. Anyway, that's all for this video.